Alrighty, good morning, period A3. This is Precalculus CP. Hope you're all having a great Thursday morning. It's the last class for seniors. I'm sure we'll have a little bit of an emotional end. I know everyone's going to miss pre-calc, but we'll get through one last class together and try to end on a very high note, all right? What we're doing today is I do want to just go through more solving trig equations problems with you. Specifically, I want to go through the practice worksheet that I posted on Classroom. I know I did not post an answer key to that, but partially because I was thinking, hey, I think it would be probably a really good idea to just go through that in class together so that we can make sure everybody fully understands what's going on, make sure there's no questions, and hopefully go from there. All right? So, and then again, the PA has already been sent out, so if you do need to get that PA done, please try to get it done as soon as possible. It is due on Sunday night. It is the last grade that seniors have to do. Some seniors already submitted it to me, which is why I sent it out early, and I appreciate that. That's, you taking advantage of the opportunity, and now you're done with pre-calc. So I appreciate you guys taking advantage of that, and I appreciate all of your hard work this year. But let's end it off on a good note with trig equations. Next week for the underclassmen, I don't want to act like this is the last thing. For the underclassmen, we are going to do a couple more complicated variants of trig equations, specifically trig equations that require factoring, so it's going to recall some of the stuff from Algebra 2. It's not like an entirely new thing, but it definitely adds one more little layer of complexity on top of it. But after that, that will be all that we got. We'll have 2 days on that, one last PA, and pre-calc will be over, which is bittersweet. Bittersweet. It should be a feeling of accomplishment to make it through pre-calc. It is a tough math class, but at the same time, I'm going to miss you guys. So, in any case, let's enjoy our last class all together as a group and see if we can solve some trig equations. All right? So, I came up with a slightly different method of trying to explain this, so I'm going to try it and see if it works out. I did it with my A4 class, and it seemed to go very well, so I'm going to do it with you guys today. What we're doing when we're solving these trig equations is we're trying to figure out what values for x can satisfy these specific equations from 0 to 360. We talked 360 degrees, or if you're working in radians, 0 to 2 pi. We talked about why your calculator only spits out specific answers. For example, the sine inverse of, let's say, -1/2 gives you an answer of -30 degrees. -30 degrees is not within your 0 to 360 range, but you can modify that by just moving it up to the +30 because you know those are going to share the same sine values, only opposite, and then looking for what angle matches up with that in the third and fourth quadrant. Okay, so it's important to understand that just because you put sine inverse in the calculator, you got -30, that doesn't mean that -30 is a valid solution because we're looking for answers specifically from 0 to 360 or answers specifically on your unit circle. Okay? So let's take a look at a couple right now and see if we can go through them. I have 6 prepared for you today. We'll see how many we get through. All right, so let's start working in degrees and then we're going to work in radians. So let's start with solve for 0 is less than or equal to x is less than 360 degrees. And let's start with a problem like this. I have 4 times the sine of x is equal to 3. Okay, some of these might be problems we did last class again, but they're always worth going over again. So this is just like algebra 1. If I had 4x is equal to 3, you would divide by 4 on both sides. The same exact principle applies here. I'm going to divide by 4. I want to isolate the sign. We get the sine of x is equal to 3/4. Just like that. All right. Now, what I identify is this is asking me the sine of some angle is equal to 3/4. It's not a pretty unit circle value, but it is a positive value. In which quadrants on the unit circle is sine positive? Well, sine of x, as we know, is positive in the first and second quadrant because sine refers to the y. So our objectives, it's almost like we can say we want to get an answer in quadrant 1 and we want to get an answer in quadrant 2 because the sign is positive in both of those quadrants. So in short, once I work my equation down to just sine of x equals a quantity, I recognize that that's a positive quantity and I can say, oh, well, my goals are to get an answer in quadrant 1 and an answer in quadrant 2. So we're going to try to set up for that. Now we turn to the calculator and I say, well, what's the sine inverse of 3/4? That's 48.59 degrees. Well, that's in quadrant 1, which is great. That's 48.59 degrees. That's awesome. We're in quadrant 1. I'm happy. Now, how do I get my angle in quadrant 2? Well, that all goes back to this little diagram of how you find reference angles. If you have an angle in quadrant 1, any angle theta, to get an angle in quadrant 2 that matches up with the same sine and cosine values, you do 180 degrees minus theta. In quadrant 3, we're going to do 180 degrees plus theta. And in quadrant 4, we do 360 degrees minus theta. So since we're in quadrant 2, I know my theta is 48.59. I'm going to find the quadrant 2 angle by doing 180 minus 48.59. And we get that our quadrant 2 answer would be 131.41 degrees, because both of those would have the same sine value, and that sine value just happens to be 3/4. Any questions about how that was done at all? We got more to do. All right, let's keep going. Number 2. Okay, this is one that we went through the other day, but worth again doing with you guys. I have 8 equals 9 times the cosine of x plus 2. Okay. In order, actually, you know what? Let's change the number. Why are we doing the same exact problem? Let's do plus, I don't know, plus 3, right? Let's change it up a little bit. Put a plus 3 instead of a plus 2. Let's see what happens. What I'm going to do is I'm going to go ahead and isolate the variable. Let's subtract 3 on both sides. That gives us 5 equals 9 times the cosine of x. I'm going to divide both sides by 9 because just like algebra 1, you're just trying to isolate that variable. You get 5/9 equals the cosine of x. And now at this point, I notice, I have the cosine equaling a positive quantity. So where is the cosine positive? Well, we know, according to our little diagram here, the cosine of x is positive in the first quadrant and in the fourth quadrant, because cosine is x, right? So any positive x is going to be your first or fourth quadrant. So that means I'm looking for an angle in quadrant 1, and I'm looking for an angle in quadrant 4. I kind of like doing this. It like sets a very clear goal of what I'm looking for. I'm looking for an angle here. I'm looking for an angle here. Now we turn to the calculator, and I do the cosine inverse of 5/9. Gives me 56.25. That's great. That's in my first quadrant. Right? And so now to find your fourth quadrant solution, you're just going to do 360 minus that. So I'm going to do 360 degrees minus my angle theta of 56.25, and I get 303.75. Because both of those angles would have the same sine, or the same cosine value in this case. Also sine value, I guess. But any question about that at all, how that's done? All right, let's take a look at a tangent example. We didn't do tangent the other day. How about 2 times the tangent of x plus 3 is equal to 1? All right, let's try to solve this equation for tangent. Now, tangent, we know, represents slope. So tangent of x is positive in the first quadrant. It's sine divided by cosine. Positive sine divided by positive cosine is going to give us a positive. Negative in quadrant 2 because cosine's negative, sine's positive. Positive in quadrant 3 because both sine and cosine are negative. So negative divided by negative is going to be a positive. And negative in quadrant 4. All right, so let's try to solve this equation and then just go from there. I would subtract 3 to both sides. I'd get 2 times the tangent of x is equal to -2. I would divide both sides by 2. I would say that the tangent of x is equal to -1. Now, the fact that the tangent equals a negative quantity, tangent equals negative quantity, that means that we're looking for an answer in quadrant 2, and we're looking for an answer in quadrant 4. Let's turn to the calculator now and see what we get. I'm going to do the tangent inverse of -1, and I get -45 degrees. Well, rats. -45 degrees is neither in quadrant 2 nor in, well, technically it's in quadrant 4, but it's not within what I meant to say, really. It's not within our 0 to 360 range. Rats. Well, what I can do is I can understand that this -45 degrees really maps to +45 degrees in the first quadrant. because negative 45 degrees is just going to have the opposite sign for its tangent, sine, and cosine values or its tangent and sine values as positive 45 degrees in the first quadrant, right? So we can say, well, negative 45 degrees, the tangent is going to match with positive 45 degrees. It's just going to be the opposite sign. So we can use positive 45 degrees as our quadrant 1 reference angle to then try to find the quadrant 2 angle and quadrant 3 angle. Okay, so in short, if you put it in the calculator and you see, ooh, negative 45, just use the positive variant because you know that those share the same values. That being said, we can now find our quadrant 2 angle by doing 180 degrees minus that 45, which gives us 135. And we can also find our quadrant 4 one by doing 360 minus 45. That gives us what? 325? Oh, 315. Sorry, 315. And so those would be our two answers, 315 and 135. Okie doke. Notice that you could have also gotten that 315, by the way, by doing negative 45 degrees plus 360. That would have taken you negative 45 degrees, which is right here in the fourth quadrant. Add 360 to go all the way around, and you end up at a coterminal angle of 315 degrees. Question about that? Feeling happy? All right, let's do a couple in radians, and then we'll call it a day. All right, couple in radians. So let's do something like this. So now instead of solving 0 to 360, let's solve from 0, which is less than or equal to x, which is less than 2 pi. Okay, that means we're now solving in radians. So let's start with something like this. We have 8 times the cosine of x plus 1 is equal to 5. All right. How do I solve a problem like this? Well, again, just like your Algebra 1 instincts would tell you to do, let's isolate that variable, subtract 1 to both sides. You get 8 times the cosine of x is equal to 4. Divide both sides by 8. You get the cosine of x is 4 over 8, or 1/2. Right? Again, you recognize, well, first of all, this is a unit circle one, so you could actually just use your circle. But assuming we weren't using the circle, we recognize that the cosine is in the first or is a positive value, right? Cosine is positive in the first quadrant and in the fourth quadrant. So those are our objectives. I turn to my calculator. If I'm going to use my calculator, I want to make sure I'm in radian mode. Radian mode. Radian. Like that. And I could do the cosine inverse of 1/2. We get a decimal, but I'm pretty sure if I convert that to a fraction, it's going to tell me it's rad 3 over 2. Oh, it doesn't. Oh, rats. It doesn't. It doesn't. It doesn't. So you know what you could do instead, actually? Why don't you just get out of that? Why don't you just leave it in degree mode and then just figure out what radian matches up with that? So if I did now in degree mode, the cosine, I thought it would convert to a fraction. That's what I get for not checking it. I thought it would display rad 3 over 2. We get the cosine inverse of 1/2 is 60. We know that 60 degrees is pi over 3. So you could say x is pi over 3. And now how do we get the quadrant 4 angle that matches up with that? Well, just like we saw before, if I have theta here, in order to get my quadrant 2 angle, I would do 180 minus theta if we were in degrees. So in radians, it's pi minus theta. In radians, this is pi, 180, plus theta. And in radians, this is 2 pi minus theta. So what I do is to find my quadrant 4, I'm going to say we'll do 2 pi minus my theta of pi over 3, which, of course, if you convert to a common denominator, that's going to be 6 pi over 3 minus 1 pi over 3, which comes out to be 5 pi over 3. And again, you could obtain those answers by just looking at your unit circle. And you could say, ooh, well, on the unit circle, that's where the cosine is 1/2. But just in case it came out to an ugly number or something that wasn't nice and neat and pretty on the unit circle, that's the actual process you would go through to find it. Okie dokie. 2 more in radians, and then we'll call it a day, like I said. So another one in radians. Let's do another tangent example. 6 times the tangent of x is equal to negative 3 rad 3. Okay, let's try this one. Just like Algebra 1, I'm going to isolate the variables, divide both sides by 6. we're going to get the tangent of x is equal to, if I reduce, negative rad 3 over 2. You see that? Now, where on the unit circle is the tangent of x equal to negative rad 3 over 2? You may not know. You may not remember unit circle exact values. But what you could recognize is that the tangent of x is equal to a negative quantity. So that means that we're looking for an answer in quadrant 2, and we're looking for an answer in quadrant 4. All right. Let's go to our calculator. Let's see. If I did the tangent inverse of negative rad 3 over 2, we get that it's negative 40.89 degrees. Rats. That's not a nice, neat unit circle one, is it? Oh, well, guess we just got to work with it. So I get that negative 40.89. How do I convert that to radians? Wait, I thought this would be a nice, neat thing. Did I mess up? I didn't mess up, did I? No, I guess it just comes out to be some ugly thing. Right? Well, let's put it in radian mode then. Let's put it in radian mode. If I did the tangent inverse of negative rad 3 over 2, yeah, we just get some ugly radian thing. I guess this is a good example of something that doesn't fall nice and neat in the radians. Oh, unless this is like no, negative 40 degrees is just some random thing. So that means that we get an answer in the calculator of x equals negative, it came out to be what? 0.71, just round, radians, right? Just some decimal. It doesn't mean that it's weird. Well, it is kind of weird, but it doesn't mean that it's like illogical. It just means that it's not one of our pretty unit circle ones. That's okay though. If x is negative 0.71, what I can do is I can convert that and say, well, that's going to share the same tangent value except just with an opposite sign as positive 0.71. And now I would just find an answer in quadrant 2 by just doing this exact thing. And that's why it's good to know this process for if you get one of these weird radians, which I honestly did not expect to show up, but I'm glad it did because it shows that I can't just look at my unit circle. I have to rely on these processes. I can say my quadrant 2 is pi minus my 0.71, which I can do in a calculator. I'm going to do pi minus 0.71. And we get 2.43 radians. And in quadrant 4, I would say we got 2 pi minus my 0.71, which would come out to be, let's see, 2 pi minus 0.71. Bang, we got 5.57 radians. Okay? It's just like what happened in degrees. Don't get confused by the fact that the radians are decimals like that. It's just like what happened in degrees. We got some weird answers over here that weren't on the unit circle, so we just had to apply our knowledge of reference angles accordingly. The same thing can happen in radians. Like I said, it's a little caught off guard that it did, but I'm glad that it did because it gave us a good opportunity to show, well, what happens if that's the case. Alrighty. Let's do one more. This is another one that we did last time, but we're just going to end with it. I think it's a great problem to end with, okay? If I have that 5 times the sine of x minus 3 is equal to 6 times the sine of x minus 2. Like I said, we ended last class with this, but I think it's another great problem. Just great to show you again. Make sure you understand what to do when you have two signs potentially in the same problem. It's just like algebra 1, where if I had 5x minus 3 equals 6x minus 2, I would get all your x's to the same side. And I would get all your constants to the same side. That gives you that negative 1 is equal to the sine of x, which means that x is, well, where is the sign negative 1? That should be automatic. It's 3 pi over 2. If you did that in an actual calculator, it's going to tell you that it's negative 90 degrees. You have to understand, negative 90 degrees, it's the same as 270 degrees, which is 3 pi over 2. That's one of our special quadrantal ones, right? If I did sine inverse of negative 1, notice it'll tell you, in degrees. Sorry. Sine inverse of negative 1 will tell you it's negative 90, and you'd have to recognize, oh, well, negative 90 is 270, which is in radians 3 pi over 2. Alrighty. So, just a little quick recap. What we did today is, that's all I have for you today. What we did today is we solved a couple equations. I just wanted to make sure I spent an extra day to really reinforce this idea. It's a super important topic, especially in calculus, that you can, if you take calculus, that you can identify something like this. If the sine of x is equal to 3/4, what is x actually equal to? Oftentimes in calculus, you will see problems that just happen to fall on the unit circle. So it's important that you keep your unit circles handy dandy if you're planning on taking a math course in college. I know you may not be thinking of becoming a math major, but a lot of science, business, any sort of engineering, programming major will all require taking math courses. So definitely good to keep that on hand. All right. But it's important that you're able to solve problems like this. We identify the fact that the sine, once you do your algebra 1 steps to actually get the solution to a problem down to here, right? Do your algebra 1. We did our algebra 1 over here. We did our algebra 1 over here. Now it's just a matter of saying, ooh, sine is equal to something positive. Well, the sine is positive in quadrants 1 and 2, and we can find what those are. The cosine was equal to something positive. That happens in quadrants 1 and 4. The tangent was equal to something negative. That happens in 2 and 4, right? And it's just going about that process here. We saw that in both degrees and in radians. Okay? Whew. Well, we're ending a little bit early today. I guess that makes up for the time that I kept you a little bit later in previous classes. And by the way, I appreciate you staying and your participation to tune in for those times where I did do that. But I just want to say to the seniors, thank you again for a great year. Hopefully, we helped make pre-calc as painless as possible, although I know it was a difficult class. I know it was a lot of struggle. You should feel an immense sense of accomplishment that you were able to get through it, and I was happy to help guide you along the way. Hopefully, you learned something, and hopefully it was a valuable takeaway in the end. But thank you again. For everybody else, I will still see you next week. Also, for seniors, it is an open invitation. You know where we're going to be next week. You can feel free to stop on by and say hello in our pre-calc classes. It's open invite, right? If you ever need me for anything, you know you can always reach out. I want to again say congrats to the seniors. For everybody else, and actually the seniors included, make sure you get that PA done. That last PA is due Sunday night, so please make sure you get that done as soon as possible. Other than that, I do hope you have a fantastic rest of your day. For seniors, best of luck in what you're doing. I hope to see you at the class reunion when that comes up. That'll be a fun time. But other than that, enjoy. You can always reach out if you need me, and take care, everyone. Bye-bye.
Bye, Mr. Giorgio.
Bethany, see you later. Thank you.
Have a nice day.
See you later, Molly.
Have a good day.
Jake, see ya.